Okay. All right, so here are some examples from section 4.1 in case you missed class. The question is to identify, what kind of triangles we have here and what's going on. One of the things is to be careful is realize that C is the midpoint of BD. So if C is the midpoint of BD, that means that if BC is 4, so is CD. And E is the midpoint of DF. So DF, if DE is 5, that means this has got to be 5. And if this is going to be 8, and this is a single mark, that has to also be 8. I'm trying to think if there's anything else they've given us. Nope, I think that's it. All right, so the question is identify, what kind of triangles we have. Well, let's see here. Equilateral isosceles or scalene. Well, number one, ABC. We don't have anything to give us about this third side here. So 8, 4, so I'd say that this has to be scalene. We weren't given enough to know what type it has. Let's say like 32. I'll do the evens because the odds are in the back. ADF, well, here's A, here's D, here's F. Well, for ADF, this is 8, this is 10, this is 5 and 5. DF is also 10, just like BD is also 8. So 8, 10, 10, that has to be isosceles. And then A to E to D. Again, we're not given what this 3 mark one is, so we have to assume it means something different. So if this is A to E to D, it's 8, 5, and then different one, that has to also be scalene for the triangle. Okay. All right, number 36 out of the books, next we're going to take a look at. It says find length x and the length of each side if triangle ABC is an isosceles triangle with AB being congruent to BC. So it means these two sides have to be equal. So 2x minus 7 has to equal 4x minus 21. Subtract 2x, add 21, add 21. 14 equals 2x, divide by 2. 7 is x. All right, and now once we know that x is 7, plug 7 in for x. 14 minus 7 is 7, 28 minus 21 is 7, 7 minus 3 is 4. And again, those two should be the same because they're both 7 and 7. Or they're both the congruent sides in the isosceles. Let's see here. Jumping into 40, let's say. Okay, 40. So we want to know what kind of triangle EBC is. So EBC. Well, we're told that this is 75 and this is 75. So for angles, we know this has to be then 150 degrees. We also know that these two sides are congruent, but I don't know if those are congruent. And these are 15 and 15. So for angles, this is obtuse for number 41. And then for the sides, EB and BC are congruent, so it's going to be isosceles. And again, I don't know that EC is the same as the other ones. In fact, I know it's not. We'll learn later on in the year why those EC is not equal to the other two. But for right now, where we're at, that's what we know. Okay. All right, and then the last type of problem I'm going to look at from this section is number 44 of the book. What they're going to ask us to do in this problem, what they asked us to do in this problem is to classify the triangle by its side lengths. Which what that means is I have to do the distance formula. So I've got some triangle out in space, let's say. It's x, y, z. So I got to find all three side lengths. So I got to find xy, yz, and xz. In order to do that, I have to use the distance formula. So x minus x, 7 minus 5 for xy, plus y minus y squared, 6 minus 1. Do your square root. Just to save us some time, we get 4 plus 25, so it's root 29. Okay. Same thing for yz. Do x minus x, 5 minus 9 squared, 1 minus 1 squared. Take the square root of that. 5 minus 9 is 4, negative 4. Negative 4 squared is 16, so square root of 16 is 4. I'm sorry, that's 0. 1 minus 1 is 0, so I skipped that. The next z, can't write. xz, 7 minus 9, and then 6 minus 1 again. So we're going to get 4, because it'll be negative 2 squared, plus 25, because it's 5 squared is root 29. Hey, look at this. These two guys match, so it must be isosceles. All right, and that's not everything in 7.1, but I think it's a little bit of everything. Hopefully it's enough to get you going. Again, if you missed class or something, or you're just confused, come in. We can go over it, and hopefully it'll make a little more sense then.